Welcome, everyone. Welcome to the presentation. Welcome to the show. It's all about digital twin for PLM, and in context of how can we make IoT work for PLM. My name is Murli Srinivas. I work for Atos, and
My name is Pugol Janakiraman. I work for Siemens PLM. I'm the co-lead for this initiative along with Murli.
thank you. Just to give you an introduction, basically, we're talking about coming from Atos. Our DNA is in the manufacturing area. We have been in the manufacturing area for several years. We have been doing PLM, the classical PLM, for several years. Things have moved on from there. We are moving from the classical PLM business, which is enterprise application, to the connected product world. So the PLM is transforming itself, the product life cycle, from requirement until the end. We're completely transforming the entire process using connected devices. And our motivation is, one of the reason, of course, is our DNA, but our partnership with Siemens and our innovation partnership with Siemens brings a lot of value here, where we are trying to leverage our joint innovation activities. We're investing into these areas. Coming to the Internet of Things, I mean, Internet of Things has been spoken a lot. You've been hearing a lot about Internet of Things. We're trying to leverage the connected products, not only for doing predictive maintenance or analytics. We're trying to use this beyond the normal business, what's going on today. So that's something which you will hear for the next 15 minutes.
Okay. So before I get deep into how we are planning to establish a digital twin for product lifecycle management processes, we should first talk about what are all the challenges and the differences in establishing digital twin across various industry profiles. Though at a high level, the innovation or the product development process remains the same, there is differences in the way in which digital twin has to be developed. For example, if you look at the high-tech industry, the innovation cycles are extremely rapid. But if you look at an automotive industry, there is very high volume and there is high complexity of the product. So there is differences in the business model depending on which industry we are going to work with. So we had to recognize these factors when we try to generate a digital twin. For example, if General Motors makes around 9 million automotives per year, we have to find a way to generate the digital twin without maintaining a static representation of a digital twin for every physical asset, like what we do in industrial IoT. So these are all the areas we have to get a bit smarter, and this is what we are trying to do as part of this initiative. But again, today, most of the customers, or quite a bit of our customers, today maintain a digital twin from an aftermarket point of view. Again, they are doing it because of this kind of product profile, where the cost of the product is high, and also the cost of the product downtime is very high. This is what is happening in the industry today. But our vision, again, is to leverage the data which is already connected to the, which they are collecting today, and leverage it for the complete innovation life cycle. Not only from a concept phase, but also from the manufacturing phase, end to end, we are leveraging it. And also we will talk about one specific use case which we have already built a complete end-to-end proof of concept for a prototype build scenario from a product innovation management point of view. But before we go there, we need to talk about one other important question which keeps coming from various our customers and also from internally within our organization. So every vendor out there is collecting data from their physical assets. So what is the differentiator for Siemens, and how are you uniquely positioned to solve this problem of digital twin, which is different from the rest of them? But for getting into that, we need to understand the complete product innovation life cycle. Today, Siemens PLM already plays in the what we call it as a virtual or a digital world, starting from requirements, design, validation, as built and as serviced. But if you look at the physical world, there is a physical manifestation of the product all through the product life cycle. The context of the data needed for the digital twin is different for every product development milestone. And also the user profile who's using the system has different expectations on the data. For example, early in the product lifecycle management, the use case is for requirements validation. So the data expected is different. But if you go later towards manufacturing process validation, we have to establish a process twin, not a product twin, to solve this problem. So our vision, again, is to bring together MindSphere IoT platform and Siemens PLM digital backbone together, establish a context-sensitive data depending on which phase of the product lifecycle management we are in, and based on user profile, provide a specific input needed to satisfy that particular milestone. We are not generating a generic one-size-fits-all twin out here. It is specific context-sensitive twin. That is our differentiator in this space again. Okay.
So, I mean, after what Pugal said, basically, we have been engaging with more than 15 customers from different industries, from different profiles, from a size perspective, have gone through the use cases and try to get our understanding of what industry needs. So we trying to, we said we wanted to do something which is tangible, which is a proof point that this works. So we took a representative product, which is a bottle testing machine. This machine is a physical machine located in Belgium. We're trying to take this as a use case to be able to capture the real-time information from the field to enable the designer, to enable the analyst to find out data or monetize the data which he gets to improve the product or to solve product requirements. So having said that, what we have gone out to say, this is a classical product change management. When we try to do the, you identify an issue, you analyze the issue, design, and then you make the changes in the manufacturing. What is key here in differentiator is we collect the data from a real device. That means devices which are running all across the world. So these machines are handling two types of, or many types of sizes of bottles, and they head for which tests these bottles have to move up and down. So there was a issue identified where the whole machine was vibrating because of a faulty design. And we tried to collect the data from different locations across the globe and feed that information directly to the designer on his desktop so that he is able to use real-time information for doing validation, for doing analysis with real data, not data which has been built. So just to give you a feeling, the machine actually looks like, I mean, a normal machine which is bottling filling machine, but this is a bottle testing machine. You see the head going, the bottles going down and the head going up and down, and this was causing vibration issues. And that's where we said we would take that as one of the proof of concept scenarios to feed that information. So as you see from the product, the real-time information of these assets are coming into MindSphere, is consumed by MindSphere, and also analyzed within the MindSphere space. Thereafter, the MindSphere with the interface which we have developed together with Teamcenter issues a note based on a collection of machine data. It's not about one machine, it's about collection of machine data. It collects that information from across the globe and feeds that data after qualifying it to Teamcenter to be able to trigger a change process. And the change process, I mean, this information, what comes in from the field, is not only used to identify the issue, it is also saved. And this is important. I mean, this point is important because this information, what you get from real-time series data, can be used for validation, can be used for analysis, and so on and so forth. Given that, I mean, this whole thing has been built based on a Mind app, and this Mind app, if you look at the Mind app, there were several prototypes of Series Build which was floating around in the world. And let's focus only on Series 2, where we had 6 machines which are taking data from different places, and the issues are consolidated. And based on these consolidated issues of the sensors, it shows where the geolocation of the device is, or the asset is. And based on this, he is able to get real-time information even while he is doing the design or analyzing the design. And you see the MindSphere data, which is a real-time data coming in, and then you can look at the issue and also the analysis, which shows the stresses it is going through and the vibration stress is going through. And that's something which every engineer would like to have the digital and the physical world in one space to be able to work between the digital and physical space to be able to make the most of the product design.
Okay. So now to recap again. So in this demonstrator, just play it again. In this demonstrator, you can see the Mind app, which the product owner can look at both physical and virtual world. But as part of the complete product development change management process here, initially the issue validation is being done by the product owner. Once he validates the issue is legitimate and approves the issue, it goes to an analyst who is validating that issue and also simulating that whole thing within our 1D tool, design tool and AMSIM, where the real-time inputs are being provided by MindSphere from the field into our AMSIM tool, and is coming up with a solution strategy for that. Again, all of the real-time inputs, boundary conditions are established from the field into the product. This is no longer established as part of the requirements process, but you have an option to get it directly from the field. And once he comes up with a solution strategy, the key here is we don't go through a prototype build. You truly trust the CAD, you truly trust the design and the validation being performed. So you're able to eliminate the prototype process in this area, and you're able to make a complete engineering release and also do a CAE simulation before that. So that is the complete closed loop PLM process we are envisioning as part of it, and the demonstrator we already built as part of a proof of concept. So key again here is, with this capability, we can completely disrupt the product innovation process, which has remained unchanged for the last 2 decades, and provide higher value to our customers to build the product in a much shorter time scale, higher quality, and also it creates a new revenue opportunity from an aftermarket point of view for our customers, leveraging our real-time data gathering capabilities, and also increases the operational efficiency. So this again is the differentiator for Siemens and Atos as part of this journey to establish a true digital twin which can disrupt a product innovation process.
To sum it all, basically, this innovation project is not about just creating a proof of concept. We continue to engage with these 15 customers whom we have spoken to. We are looking forward to taking that on a real customer data, real customer asset, and a real customer products to be able to put that solution together for whichever use case the customer thinks appropriate. And really thankful to the to joint innovation which is happening between Atos and Siemens, which we are leveraging to the best of our extent.
Yeah.
Thank you.
Thank you.